Okay, guys, today we're going to finish up your science review. So we're going to do 16 through 19. All right. Okay, comparing sedimentary rocks to fossil fuels. We have done this before on your notes, so we're just going to review that again here. So sedimentary rocks only, fossil fuels only, and then things that go with both of them go in the middle. So we're going to I'm just going to start at the top and work my way down. So cementation goes under sedimentary rocks. That is the last step in the process when all of the sediments get glued and stuck together, would be the cementation. They get cemented together. Compaction is also, now, typically we only use compaction to refer to sedimentary rocks, but technically there is compaction happening with fossil fuels also, because compaction is just the squeezing. Compaction happens anytime you have pressure, and we know that we have pressure with fossil fuels as well as sedimentary rocks. So we'll go ahead and put that one in the middle, because while we typically use that term when we're talking about sedimentary rocks, it's technically applicable to fossil fuels also. Okay, and then heat and pressure is, of course, both of them. Both sedimentary rocks and fossil fuels require heat and pressure. Fossils get trapped in the layers. So this goes under sedimentary rocks. So that can be confusing because you think fossil fuels would contain fossils, but they don't. Fossil fuels are made from the remains of organisms that decompose and change into a fossil fuel like coal or oil. Whereas a fossil is actually an imprint or a hardened remain of like bones, or an imprint of the shell, or an imprint of the footprint, or things like that. So they don't change into oil. The fossils themselves are just the remains of the animals or the plants. So that goes here. We always find fossils in sedimentary rocks because of the layering. Okay, made from dead organisms would go under fossil fuels only. While sedimentary rocks can contain fossils, they're not made of organisms. They're made of sediment. And so that brings us to the next one. Layers of sediment make up a sedimentary rock. Millions of years goes under both because they both require millions of years to be formed. Used as an energy source goes under fossil fuels because we cannot burn sedimentary rocks for energy, but we can use fossil fuels. And then made from sediment goes under sedimentary rocks. All right, 17. Okay, so we are looking at rock layers. We've talked about this a little bit on warm-ups. So I'm going to show you this video, and then we're going to go over some of these things over here.
There are three basic laws of relative rock dating. They are the law of superposition, the law of cross-cutting, and the law of inclusions. First, let's define what we mean by relative rock dating. Relative rock dating is where we determine the relative or comparative age of rocks to each other. This means that we know which is older and which is younger, but we don't know exactly how old they are. Determining an exact age of a rock is what's known as absolute or radiometric rock dating. We use relative rock dating laws to determine the relative ages of rock layers or features to each other. Again, we're only able to determine what is older and what is younger. Let's look at each of these three laws. The first is the law of superposition. The law of superposition states that in an undisturbed sequence of rocks, the oldest rocks are on the bottom and the youngest rocks are on top.
Okay, now he's getting fancy with all these laws and the names of them, but the main thing that I want you to take away from this, if you can remember law of superposition, that is awesome. You'll be ahead in the years to come, but we don't need to know what it's called in 5th grade. What we need to know is that the oldest rocks are on the bottom and the youngest rocks are on the top when you are looking at layers.
Rocks are on the bottom and the youngest rocks are on top. We can compare this to an analogy of a laundry basket. Each day as you add dirty clothes to that laundry hamper, the layers stack one on top of the other. And as long as this stack is not disturbed, the oldest clothes will be on the bottom and the youngest will be on the top. The same is true with any undisturbed rock sequence. The oldest rocks are on the bottom and the youngest are on top. Let's now look at the law of cross-cutting. This law states that any feature that cuts across the sequence of rocks is younger than everything it cuts. Some of the features that cut across the rock sequence may be a fault or an igneous intrusion, either a dike or a batholith. And these features are younger than any part of the sequence they cut across.
So he mentioned that these are called inclusions. We don't look so much at faults in 5th grade, although it's helpful to know that they are younger than anything that they are going through. We do look at magma intrusion. And so I showed you what that actually looks like in a warm-up from last week, I believe, what that looks like in action. But when you see it in a diagram, when you see that diagonal slanting across the rock layers, that is the youngest layer.
They cut across. Let's compare the law of cross-cutting to tracks in snow or in sand. In this scenario, the older tracks will be covered by younger tracks. This allows us to determine the relative age of those tracks, where those that are on top or are not covered by anything are the youngest, and those that are covered by the most are the oldest. This is also true with any rock sequence with cross-cutting features. Those features are younger than all of the rocks they cut. Finally, let's look at the law of inclusions, or as it's also known, the law of included fragments. This law states that any rock or fragment that's included inside of another rock is older than the rock in which it's included. For example, if we look at this diagram, pieces of rock A are inside of rock B. This means that rock A is older and rock B is younger. This is because rock A had to be around first so that it could be included inside of rock B. An analogy that's similar to the law of inclusions is that of a fruitcake. A fruitcake includes a lot of chunks or other items, and those items or chunks had to be made and bought before they could be included in that cake. So what this means is that those chunks are older than the surrounding cake. The same is also true for rocks. Any rock that's included inside of another rock must be the older of the two. Again, we can use these relative rock dating laws to determine the relative or comparative age of rocks to each other. Again, this only means we can tell which is older and which is younger. We must use something else known as absolute or radiometric rock.
Okay, I'm going to stop there because we don't need to know about radiometric dating. I don't want to fill your brains with so much that you can't hold on to what I want you to remember. What I want you to remember is how to tell the relative age of rock layers, especially when there is a magma intrusion. So when you just have straight up layers and there's no intrusion or no cross-cutting, then the oldest layers are on the bottom and the youngest layers are on top. And same goes for the fossils. Any fossils contained in that layer would be younger on top, and the deeper buried fossils are older. When you have magma intrusion present, the magma intrusion will always be the youngest because it had to come, all these layers had to be formed for this magma intrusion to break up through them. And so we know that those must have been there first, and the magma intrusion came later, which came more recently, which would make it younger. So we're going to drag the labels to, let me grab them. So these are text boxes, so you're going to have to click on them and then wait for your arrow to turn into that 4-way, and then you can drag it. Okay, so oldest would be here. Both bottom layers would be oldest. And so this fossil is also the oldest of the 4 fossils. All right, youngest layer here, since we don't have any magma intrusion, the youngest layer will just be the top layer. It's very simple when you just have layers. When you have magma intrusion, it's a little bit trickier because you have to remember that while the top layer is younger than the others, it is not the youngest. The youngest would be the magma intrusion. I'm going to turn this. Okay. And then younger layer would be any of the middle layers would be younger than the bottom layer. All right, if 3 fossils were found in a layer of rock, what does that tell us? And I'm just going to highlight, we don't have our little circle, so I'm just going to highlight. So tree fossils are found in a layer of rock, then that would tell us that there must have been a forest at one time. So I'm going to highlight C. All right, 18. All right, how does light travel? Remember that light always travels in a straight line. Think of like a laser pointer or a flashlight beam. It's always radiating out in a straight line. Okay, and then we're going to define and drag the pictures to each correct spot. So transmit is to travel straight through. So that would be like this picture. So the light is just going straight through. It's not bending, it's not bouncing back, it is just transmitting straight through. So examples of things that transmit would be a window, clear, plastic wrap. Okay, absorb is to take in, or in the case of light, I like to say that it stops it, because that helps you know that it's not traveling through. So black paper, any solid object is going to absorb. And so the picture that goes with that would be this one. So with absorption, the light literally hits and then stops. It does not come through the other side and it does not reflect. All right, reflection is when the light bounces back. It bounces off of smooth, shiny surfaces. So that would be like mirrors, tinted windows, smooth, shiny metals. All of those would be able to reflect. And here is a great picture of reflection. Oh, you can make that bigger if you want to. So you can see the light hitting the mirror and reflecting at the equal opposite angle. Remember the law of reflection. The angle of reflection matches the angle of incidence. So if it comes in at a 30-degree angle, it's going to bounce off at a 30-degree angle. All right, and then refraction. Light bends as it travels through. So with refraction, it's important to note that it is being transmitted, it is traveling through, but it's bending on its way through. And so lots of things can refract: lenses, water. And then so if lenses refract, then anything that has a lens is going to refract. So a camera, a projector, a microscope, anything that has a lens is going to refract. And lots of lenses, lots of tools that use lenses like microscopes and projectors actually use both reflection and refraction. But the lens part of them, the part that lets the light through and bends it, is the refraction part. And then the picture would be this one. So you have the straw in water, which is a very classic example of refraction, where the straw looks broken, or you can see here the actual light traveling into the water and bending. All right, now slide 19 is all you. I'm going to do the first one with you to show you what we're doing here, but the rest of them are pretty straightforward, and you're going to do them on your own, and then I will check them. Okay, so what you're doing is you're just completing the table about the properties of matter. Remember, properties of matter are magnetism, solubility, density, physical state, conductivity. Okay, so you're just putting yes or no for each one. So oil is not magnetic. It is not soluble. It is not more dense, so no to more dense. It is a liquid. It is not a conductor. So you're just putting yes or no in every column except for physical state. In physical state, you have to put solid, liquid, or gas. But in the rest of the columns, you're just answering yes or no to the question. Is it magnetic? Is it soluble? Is it more dense? Is it a conductor? And that is all you're doing. So once you finish that up, you can turn this in. We will be done with the review. And so this will be available to you to study. So this is what you are using along with Study Stack to prepare for your science exam next week.